Hello students, welcome. Today we are going to dive into the exciting world of linear equations, but first, let's take a little journey back. Remember when we solve simple equations in one variable, like x plus 1 equals 0 or x equals minus the square root of 2? You probably recall that these equations have one unique solution, and we can easily represent that solution on a number line. For instance, x equals minus 1 is a solution that you can pinpoint exactly at minus 1 on the line. Simple, right? Well, we are going to extend this concept and take it to a whole new level by exploring linear equations in two variables. Now, let's move on to linear equations in two variables. Imagine a relationship between two things like the cost of apples and bananas. For example, x plus 2y equals 5 is a linear equation where x and y are our two variables. What's interesting here is that there isn't just one solution. Instead, this equation has multiple solutions, or what we call an infinite set of solutions. You can think of this as finding many pairs of x and y values that satisfy the equation. The general form of a linear equation in two variables looks like this: ax plus by equals c, where a and b are constants and x and y are the variables. Sounds a bit more complex, right? But it's all about relationships between the variables. You'll see soon that we can represent this equation graphically and visually. Now, let's get visual. A linear equation in two variables is best represented on the Cartesian plane, where the solutions to the equation form a straight line. Let's take our example again, x plus 2y equals 6. If we choose some values for x, like 0, 2, or minus 1, we can solve for the corresponding y values and plot them on a graph. For instance, when x equals 0, we get y equals 3. If x equals 2, then y equals 2. By plotting these points, we can draw a straight line that represents all the solutions to the equation. And there's the beauty of it. The line is essentially a collection of all possible solutions. This is one of the key aspects of linear equations in two variables. The solution isn't just one point, but a line of points. Now you might be wondering, does every linear equation in two variables even have a solution? Well, yes it does, but there are some exceptions. Most of the time, a linear equation has infinite solutions. For instance, the equation x plus y equals 4 has an infinite number of solutions. Any pair of numbers that add up to 4 will work, such as 1, 3, 2, 2, 3, 1, and so on. However, there are some cases where there are no solutions. This happens when the equation is contradictory, like 0x equals 0y equals 5. This equation can never be true because there's no set of values for x and y that will satisfy it. So while most linear equations do have solutions, there are rare cases where there are none. Now let's explore a very interesting question. Are the solutions to a linear equation in two variables unique? Well, the answer is no, they aren't. In fact, linear equations in two variables usually have infinite solutions. Think about this. If x equals 1, then solving for y in the equation x plus y equals 4 gives us y equals 3. But you can choose different values for x and get different corresponding values for y. This is why the solutions aren't unique. There are many points on the line, and each one is a valid solution. The key idea here is that the equation gives us a relationship, not a single solution. To wrap it all up, today we explored the concept of linear equations in two variables. We started with linear equations in one variable and saw how these simple equations have a single solution. Then we extended this idea to two variables where the solutions form a straight line on the Cartesian plane. We learned that these equations usually have infinite solutions, and they can be graphically represented as a line. I hope this gives you a clearer understanding of linear equations in two variables and how to work with them. keep practicing, and you'll see how powerful and intuitive this concept really is. See you in the next lesson.